Welcome to Homework Lib.
Chapter 14, question 102. We have a question that is a little bit difficult to solve with the things that we learn in this chapter because we need to also know a law for absorption. That is A equals to ELC. Now A is the absorption and E is the extinction coefficient. L is the length that the light is traveled, so it's 1 centimeter cubed. It's going to be 1 centimeter. And C is the concentration. So now what we want to do is we want to find the concentration. And to be able to do that, what we can do is simply write the values for the absorptions, these values, and divide all those values by the extinction coefficient. Since the length is 1 centimeter, we don't have to bother with that. And we're going to find the concentrations for each of those values. I'm going to write just 2 of the values since we don't need more than 2 data. 2.66 times 10 to the power of negative 5. And this is going to be 2 times 10 to the power of negative 5. Now, to be able to find the rate law, we need to draw a graph for these values. So this can be 0th order, 1st order, or 2nd order. We rule out the first 0th order because this should decrease if you draw the concentration versus time, this should have a straight line with a negative slope. We don't have that. This rather looks like when we write the concentration versus time, rather looks like this. And this can be 1st or 2nd order. So to be able to determine, we can just simply try 2 different graphs. One is ln of AT versus time, and the second one is 1 over AT versus time. Now, when I draw these, I encountered a problem that was quite interesting because at LNT, I got a graph with 2 data points over here, and then a breakage and a little bit curvature with these 3 data points. Whereas 1 over AT gave me 3 data points that are perfectly on a straight line, and then an outlier, and then a straight line. So I'm thinking what we're looking at is a 2nd order. So if we go through this integrated rate law of the 2nd order, what we're going to get is 1 over AT equals to KT plus 1 over A0. So for 1 over AT, we get the value over here and convert that to the concentration. So it's going to be 1 over 2 times 10 to the power of negative 5 equals to K. T is going to be 30 times 60 since we want seconds. So this is going to be equal to 1800. K times 1800 plus 1 over A0, which is 2.66 times 10 to the power of negative 5. So if we solve for K, what we're going to get is 6.0 97. And the units for K, let's go with that too. K a to the power of 2 equals to molarity over time. So this A is a molarity unit. It's going to be a molarity over time. So the K's units are going to be 1 over m. Instead of time, we can write seconds. So it's going to be 1 over molarity seconds.